Good evening, everybody, and you're very welcome to this evening's Transition Year webinar for science teachers, which ties in with our Bridge the Gap series for Transition Year Chemistry, Physics and Biology. By way of introduction, my name is Connor Walker. I work for Folens post-primary publishing team, and together with Sean, Declan, David and Wesley, I was involved with them in the production of our fantastic Bridge the Gap science series. Before I move on to the agenda, I wanted to take some time to thank all of you for joining us this evening. I know it's a very busy time for teachers. Every week is a busy time for a teacher, really, but coming back from the midterm break, you're probably busy getting up to speed on everything again. You might be preparing for the upcoming science week and so on. So we really do appreciate your time, but we're sure that it's about 45 or 50 minutes of time that will be well spent. So here's the agenda for today. We're effectively going to present on each of the books that we've produced for TY Science. But really it's more than that, because we'll be looking at the various chapters, and through the structure of the book, we'll be looking at how the gap, I suppose, can be bridged between junior cycle science and physics, chemistry and biology respectively. But also Sean, Declan, David and Wesley will give really good advice through the structure of the book on how to achieve effective teaching and learning of transition year science subjects, and also to look at interesting topics that might be good to teach at transition year, and hopefully encourage students to develop more of an interest in those science subject areas and possibly take up more science subjects going into Leaving Cert than they would have otherwise planned to. So to begin with, we'll be listening to Sean speak about transition year physics. Sean is a teacher of physics, chemistry and science in Gaelcholáiste the Carrigaline. Sean is currently the chair of the ISTA, and he is also an author of Folens. He is the co-author of Essential Science, which he wrote with Declan and Rose Lawler, and also he wrote our Smart Study Science book as well. That book was written, or the physics book was written with Robert O'Neill, or Robert Nolan, I should say. Robert isn't available, unfortunately, today. He chose to get married, which is, put a complete kibosh on his ability to present here today. But Robert sends his apologies, and we send our congratulations to him. Then moving on to chemistry, Declan Kennedy is a name really, as most of you will know, synonymous with science education in Ireland. Declan taught science for over 20 years at secondary school level, and he's now teaching at UCC, where he's involved in training science teachers. He's very closely involved with the ISTA and is the coordinator of its national CPD program for science teachers. Declan is also a successful Folens author with his Chemistry Live book for Leaving Cert Chemistry, and also the Essential Science book, which he published for junior cycle with Sean and Rose Lawler. Then chemistry, Bridge the Gap Chemistry was co-authored with David O'Connell. David is a graduate of UCC with a BSc in Science Education. He's currently teaching at CBC Cork, which he has been doing for the past 10 years, and has a wealth of experience in delivering CPD through the ISTA and also the ChemEd conferences down through the years. Excuse me. David was also instrumental in the creation of the videos that we produced for Chemistry Live and Essential Science. Then finally, when Wesley presents, he'll be talking about TY Biology. And Wesley, again, is a highly experienced science teacher. He teaches science and Leaving Cert Biology up until quite recently at Our Ladies in Terenure in Dublin for about 12 years or so. And now for the past 4 years, he's been teaching Leaving Cert Biology at the Institute of Education in Dublin. So quite a stellar cast of actors that we have today. I'm humbled to be in their company. Then after the presentations, which should take about 40 minutes or so, maybe a little bit less than that, we'll have a Q&A session. So during the course of the webinar, if you'd like to post a question to our authors, please do that by clicking the question button, which you should see at the bottom of your screen. And we'll collate those questions and we'll get through as many as we possibly can during the Q&A session at the end. There's also a survey, if you wouldn't mind completing whenever you leave the webinar. It's just a single question, but would be particularly helpful for us if you have an interest in discussing the TY programs a little bit more. Okay, so I think that's it more or less from me. I'm going to very shortly hand you over to Sean. I'll disappear for most of the presentations. I'll return at the Q&A piece, but in the meantime, it's over to you, Sean, and best of luck.
Thanks, Connor. So I am introducing here the Bridging the Gap physics booklet. So what I've noticed myself is that as a teacher of physics and chemistry and junior science over the last 25 years, we've had a number of syllabus changes, and every time the syllabus changed, there was less and less physics being covered. So in the next slide, we'll find out what physics has been removed from the previous science syllabus. Okay. So hopefully you're seeing the presentation. Okay. So what physics has been removed from the previous science syllabus? Reflection, refraction, and the spectrum, static electricity, sound, magnetism, wave motion, and this has led to a number of gaps in the knowledge from junior cycle in topics very relevant at leaving certificate level. So in the next slide, what we show is what we show now. Sorry to interrupt you, Connor. I can't see the slides in front of me. I just see my own image.
Okay.
So can anybody else see the actual slides? I have printed out slides in front of me.
No, I cannot see the slides either, Sean.
Okay, thanks, Declan. So can we present the slides, please, in due course?
Yeah. Apologies, Sean. Can you see that now? Can you see that now?
Thank you, Connor. Yes, please. Yeah, perfect. So you make that in presentation mode. Okay. So how Bridge the Gap addresses these areas. So in the next slide, so in these two slides, we just have a summary, just what is in the contents, and I'm going to go through each of these areas in more greater detail. Okay. So we want to move forward there and move forward again, Connor. One more again. Okay, so on the next slide now, we're going to look at each of these topics in greater detail. So the first one we have here is scientific notation. So this may be pre-taught by your maths teacher or by yourself. It may or may not be. And this, of course, is right. So what we do is we look at small numbers and how to convert them to scientific notation, how to convert large numbers, and to use your calculator. Then, as Connor has on the screen, we go on to chapter 2, where we cover light, reflection, and vision. So the experiments are just junior sort of experiments. They're just maybe put a little bit, they are probably a little bit more than junior cycle, and just slightly more in that they just have to do a little bit more measurement, not just observation. So we look at here the reflection and the periscope. Again, lots of STS, bringing forensic science into it, how they use diffractive index in order to find out about glass and accidents and where the gases come from. And then we look at refraction as well. So it's done at the junior cycle level, but it's just a little bit higher, where they do a little bit more measurements. And in the next slide, so the next slide, and we're still on chapter 2. So in the next slide, we're continuing with light and vision. Okay. So we're on light and vision, the previous one to that. Yeah, thank you. That's it. So light and vision, we look at refractive index, right, how to get it and how it's used in medical physics and the use of endoscopes and keyhole surgery. We look at the medical physics of the eye. We look at eye problems and how to correct them with their glasses. And we look at lenses and how to determine the focal length. In the next slide, chapter 3, we look at heat and heat energy. Now, anytime I go into a lab, your kids are asking me, their kids are always asking me, Miss or Sir, are we going to do an experiment today? So I have put plenty of practical work here. I like doing these experiments with the students. So expansion of solids, liquids, and gases, and then the heat being transferred by conduction, convection, and radiation. So in the next slide, what we'll find is what we cover is latent heat. Now, latent heat comes up, of course, in leaving cert physics, maybe a little bit as well, maybe in tangentially in physics. And then we look at Lord Kelvin, and we look at the famous scientists. We look at just converting degrees centigrade to Kelvin scale. We look at the physics of architecture, how we can reduce conduction, convection, radiation. And again, we look at the Kelvin scale. So in the next slide, what we will find is in chapter 4, we look at magnetism. Now, they would have gone through junior science without doing magnetism at all. They do a little bit in primary school. So a lot about magnetic fields. They look at how to make an electromagnet for themselves. They look at how the Earth is protected using the Earth's magnetic field, creating the aurora borealis. And then they look at how motors are created. And this is just a simple experiment where this piece of foil jumps when a current is put through it. It's the principle in which a motor works. So this is just a starting ground. Again, it's just junior science and a little bit more on top of it. Nothing too taxing, but everything is in the book, and it's a complete package together that you can that is perfect for teaching, hopefully. So chapter 5 and static electricity. We look at just the basics of static electricity because it comes up a small little bit in chemistry. We look at the electroscope and how to detect it, the Van de Graaff generator. We look at lightning conductors and the hazards of static electricity. So in the next slide, in chapter 6, you will find in chemistry that you are going to talk about wavelength and frequency and that, and they're not going to have met that at junior cycle at all. Now, unfortunately, they would not have met that in the previous syllabus either. So we're going to do a little bit of work on frequency and wavelength, about spectra, about the electromagnetic spectrum as well. So this should help both physics and chemistry. And we do very simple calculations here. Now, we were very careful when we were choosing the depth treatment in this, that we try to give it a bit more visual appeal rather than mathematical appeal. But there's just a very small bit of essential mathematics that would have been covered maybe in the intercert when I was in school. So in the next slide, right, we look at waves and wave motion again, just touching on spectroscopy. We look at why is the sky blue? Now, it should be black. Right, but we look at the scientist John Tyndall, an Irish scientist that discovered this. We look at the medical physics of X-rays and how X-rays are produced and how we can make light X-rays or heavy X-rays for radiotherapy. And then we look at the physics of aviation and the radar. In the next slide, what we find is we look at sound, right? And we look at sound as created by vibration. We look at things like frequency and amplitude. And we go a little bit into the physics of music on musical instruments like pipes. We look at the amplitude and frequency and how that affects the sound. We just do a non-mathematical treatment of the Doppler effect. So that is, why does the frequency of an ambulance change? It's a high pitch approaching you and a low pitch passing you by. And how this is used in astronomy for determining the speed of galaxies as they move away from us. We also look at the ear and the smallest bones in the body. So in the next slide, what we cover. So what I'll do, folks, is I'll pass you over to Declan Kennedy, who will speak to you now on the chemistry side. Thanks very much for your time.
Great. Thank you very much indeed. And David and I are going to divide our time fairly equally between the chemistry bridge the gap. So if I could have the next slide there, please, Connor. And I suppose the first question we should ask ourselves is, well, why is there a gap in leaving certificate between junior cycle chemistry and leaving certificate chemistry? And if you look at some of the items that have been removed from the syllabus there, you see that students no longer do any experiments to show that burning uses up oxygen in the air or measuring the percentage of oxygen in the air. Also, students come out of junior cycle science being able to write only the formulas of compounds containing 2 elements. And yet at leaving cert, they meet sulfates, carbonates, hydrogen carbonates, nitrates, and so on. So every single one of the items in that list on that screen are related to the leaving cert chemistry course. And on the next slide, you will see our table of contents. And I suppose the first thing that will strike you about that table of contents as you cast your eye over it is that there's a considerable emphasis on environmental chemistry. And the reason why we have that considerable emphasis is to reflect the huge emphasis on environmental chemistry at leaving certificate chemistry level. And on the next slide there, you will see that in the first chapter, we zoom in on the air that we breathe. And we look at the composition of the air, evidence that the air is a mixture of gases, and basically cover the whole theory of combustion. And on the next slide then, what you can see is evidence that air is a mixture of gases. We look also at the simple idea of how the theory of combustion can help us explain what happens when a candle burns. And also we look at the fire triangle. And none of these topics are on junior cycle science, but vital to have at leaving certificate chemistry level. And then on the next slide, you will see that we try to pick up on some of the areas that are gone from the junior cycle science syllabus. And we look at the preparation of oxygen. And remember, the preparation of oxygen is not on the current junior cycle science curriculum specification. It's the rate of production of simple gases. So the apparatus that they use is different, and also the experiments that they carry out studying the properties of oxygen, like the manufacture of acidic and basic oxides, are important areas for leaving cert chemistry. And on the next slide then, you'll see that we also cover nitrogen, because this is an important area for leaving certificate environmental chemistry. And not only do we cover how liquid nitrogen is made, we look at the uses of liquid nitrogen in everyday life, in food, and in the area of medicine. On the next slide, we look at the whole area of water, because an understanding of the properties of water is vital for an understanding of environmental chemistry. And as you can see there, from the objectives of the lesson, we have the treatment of water and also hardness of water covered, all of which are gone from junior cycle. And on the next slide, we feel it's important that students understand some of the fundamental properties of water as summarized there on the left, and also understand how water is treated before being pumped to our homes. And on the next slide, as you can see there, we look at hard and soft water. Now, on every chapter in the book, we have laboratory practical work, because this is a great way, of course, to promote our subject among our students. And as you can see, not only have we the experiment there, but we also have some applications of science through science, technology, and society. So, for example, the formation of stalactites and stalagmites, and we also include famous scientists. Like here, we felt that Kathleen Lonsdale from County Kildare would be a good example, a good role model of a scientist, because she was the lady who discovered the structure of benzene and was a really top-class X-ray crystallographer. And on the next slide, then, we look at the whole area of the removal of hardness, the problems caused in the home by hardness. Now, we fully realize that there is a huge gap about writing chemical formulas. So what we've included on the final page is an appendix in which we have the chemical formulas of a whole range of ionic compounds. This would be useful even for current leaving cert chemistry students. So that nice, neat little summary is something that you dip into. The best way to do this, of course, is to drip feed it as we go through. But nevertheless, to have it all on the one page will be very helpful for you. And on the next slide, then, we talk about chapter 4, we have plastics in our lives. Now, this is a very important area because, again, it's laying the foundation for later discussions of environmental chemistry and the importance of recycling plastics, and as well as dealing with the manufacture of plastics. And on the next slide, dealing with plastics, we start with a nice little introduction to show students what was the first plastic made, who invented the first plastic, and why are plastics such important materials in our lives. And then in the next slide, after introducing it, we have a nice summary table there of the various plastics that students meet in their everyday lives, from the polythene that they meet in their rubbish bags, down to the polypropylene that they have in the plastic beakers inside in the school laboratory, to the PVC that they see in their windows and doors. And we use this then as an entry point to the whole area of polymerization. And we explain how these molecules arise, then from starting with industry's most important organic chemical, ethene. And in this chapter, we prepare a sample of ethene. And on the next slide, you will see that as well as looking at ethene as a case study, we also look at PVC as a case study. Where does it come from? And we show the chemical formula on the left, and next to it then we show the molymod molecules coming together to form our long chain. And continuing on that, in the next slide, we move from PVC and we look at Teflon. Again, one of the most useful plastics that we have. And you can see again how that's made from tetrafluoroethene, polymerizing it to form polytetrafluoroethene, or Teflon. And we explain how it was discovered quite by accident, and the use of Teflon in manufacturing body parts, as well as in frying pans and in plumber's tape. And then on the next slide, as you can see there, we now get cracking because we've covered the fundamentals that they need for environmental chemistry, and we go on to water. And here we're going to look at water pollution in particular. And on the next slide, you will see that dealing with water pollution, we introduce it by looking at some case studies. Why is it that fish die due to a lack of oxygen? How is oxygen dissolved in water? How do we measure the amount of oxygen that is dissolved in water? And on the next slide, we then look at various examples of other types of pollution, the addition of nitrates and phosphates, the need to recycle batteries to avoid the heavy metals like nickel and cadmium and lead ending up in our waterways. And we do some nice test tube experiments, bringing the students through the tests for nitrates, phosphates, chlorides, and so on. And on the next slide, then, the final chapter deals with I forgot to mention, we also do the treatment of water. If they live in a town or in a city, they will obviously have a sewage treatment plant, as shown there on the left-hand side of the screen. If they live in the country, they'll have a septic tank for treating the sewage, and we deal with the chemistry and the environmental impact of both of these systems. And then on the final chapter, on the next slide, we look at the chemistry of the atmosphere, a very important area of chemistry, particularly for leaving cert chemistry. And we're looking at the greenhouse effect here, as well as, of course, the ozone layer. And on the next slide, we introduce it by talking about the importance of global warming and the importance of following the science, as Luke O'Neill keeps on telling us. And we have some examples there of the main greenhouse gases that the students will meet, as well as some formulas to bring in bonding. We sort of drip feed chemical bonding throughout the course rather than give it all in one dollop to avoid information overload. And then on the next slide there, we look at the whole area of atmospheric pollution and the concern about the depletion of ozone, and explain the science behind that depletion. And finally then on the next slide, we end up with talking about CFCs, their discovery, and why these CFCs have caused a huge amount of damage to the ozone layer. So at this stage now, I'll pass over to David to bring us through the forensic science.
Thanks very much, Declan. So hello everyone, and thanks very much for joining. So this section of the book is a unique selling point really for forensics, and obviously is an interesting topic for students, but you can use this section in any TY module, in a science club, science week next week. And I've tested and tried all of the experiments and all of the various areas covered in the topic myself in class, so hopefully you can see from the table of contents, there's a nice range there of activities that students can do. So moving on, you can see that like every chapter, we put in the objectives at the start and the keywords throughout. So that's for literacy, building up the vocabulary and so on that students would need to be familiar with. And we have famous scientists and real life examples covered as well. On page 31 and onto page 32, then you can see Edmund Locard, which would be the father of modern forensics, and real life examples of crime scene and gathering evidence there. So it goes through examples. You can get discussions going from films and television that students be familiar with. Now, the experiments then, the first experiment that we'll cover in this chapter is very simple, interesting experiment where students can look at their own fingerprints. And this is very interesting for students to do because they can see that there's one of the three patterns, the loop, the whirl, or the arches, and it's very simple equipment that can be easily picked up from €2 shops, from supermarkets, from arts and crafts shops, things like that as well, and just using common equipment that you already have around the lab. So building on from that, then we look at hair and fiber, and we look at the difference between, say, synthetic fibers, natural fibers, so from their uniforms, from their jumpers. That will obviously link in then to physics, with the microscope and lenses, using the magnifying glasses. With biology, we're looking at the structure of the hair, and with the fibers themselves, we're looking at, say, synthetic oil-based ones, which would link into chapter 4, versus the natural ones from plants and animals. So the next experiment then we decided to pick was to do with chromatography, and students be familiar with this section from the junior cycle chemical world strand, where they would do chromatography to separate out the ink. So we've taken that experiment, but we've kind of delved down further into the fundamental principle of chromatography and started to introduce now the key terms like mobile phase, stationary phase, solvent selection, and some of the instruments that you'll see in a minute that will be essential for the students if they go forward to study Leaving Cert chemistry. So it is giving them a great foundation, but doing it in a context such as in the theme of forensic science that kind of engages them there, the whole area of fake IDs, forgeries and art, fake documents, fake registration plates, the inks and all that can be separated out from those. So the next experiment then in the chapter looks at a bit of inorganic chemistry, and the flame test is a simple, quick experiment to do. But again, from my own experience teaching this with students, that they love this particular experiment. It's very useful for open nights as well, so you get some ideas from the books for activities that you could do around there, for, as I said, for Science Week, for outreach, for science clubs, and obviously for TY modules themselves. So the experiment there just takes the 4 basic simple metal salts, your sodium, potassium, strontium and copper, burn them in the flame, and again, in the context of forensics, this fits in with, say, gunshot residue, metal fragments from cars, from hit and runs, collisions, that sort of thing. Now, moving on, we can see then that this allows us a perfect kind of springboard to jump in and talk about the instrumentation. So around gas chromatography, HPLC, liquid chromatography, and mass spectrometry there, which can be used as detection methods. Again, real advanced, high level, interesting areas now that can be discussed here, depending on the level of your students and the time you have allocated to them to be able to discuss all of that. And again, that would lend itself very well to giving a context for, and a foundation for Leaving Cert chemistry. We've included then next a very interesting, relevant and age appropriate case studies, and for example, how fingerprints were used in the kidnapping case and how chromatography was used in catching the famous Curry killer. At the end of the chapters then we have learning outcomes and summaries, and then we have a bank of questions then that can be used for assessment, both in class, for homework, for formative or summative assessment. Finally then, throughout the book, there are, I think, in total 13 different research projects. So for my own students, I've given them the choice of choosing whichever one of the 13 projects they want to do themselves. They have to use their creativity skills, their research skills, their communication and presentation skills, come up with one of those projects and present to the class. So again, that can be used as a TY module. It could be used as a form of assessment. And it does kind of, again, promote, you know, further learning in the topics, and then use them to form a good foundation, as I said, hopefully encourage them to pick up chemistry at Leaving Cert level. So thanks very much. I'll pass you on to Wesley there now, who's going to talk through the biology Bridge the Gap book.
Hi everybody, thanks David. So just on the next slide there, Connor, you'll see what students now going into Leaving Cert biology lack So they lack the basic knowledge of the feature of enzymes, structure and function of the skeleton, excretory organs and their functions, the nervous system, like what are neurons, the feature of the eye and the ear. So these things are no longer covered in the new Junior Cert, Leaving Cert course. So if you look at the next slide there, you'll see that chapter 1, chapter 2, chapter 3, and chapter 4, and on the next slide you'll see chapter 5. These are topics that were once covered in more detail in the Junior Cert, and now obviously the new Junior Cert course, a lot of them topics are lacking. So them 5 topics really give students a good introduction into that area, and they get a bit of a head start then in the Leaving Cert biology course when they cover them topics. Chapter 6, 7, and 8. They are covered in some in bits of in part of the course in the Junior Cert, but we just dip into them in a little bit more detail, and we introduce a few new ideas as well. So on the next slide there, you'll see there chapter 1. So what do we do in chapter 1? We look at enzymes, features of an enzyme, factors affecting enzyme action, and we look briefly at the idea of an immobilized enzyme. So if you go on to the next slide there, you will see that we introduce the idea of how temperature affects enzyme activity, how pH affects enzyme activity, and we really make this relevant to the students. So throughout the entire book, you'll see these "Did you know" pop-ups on nearly on every page that students will find very interesting. So you see there in the bottom right there, a "Did you know" box where why does food go off more slowly in the fridge? We introduced the idea of temperature being lower, so it slows down the enzyme activity inside the bacterial cell, so bacterial growth is slowed down, so therefore the food goes off more slowly. On the next slide there, you'll also see the idea of we use 4th year as an opportunity to make things more relevant. So we look at enzymes and how it is relevant to our everyday lives. So we look at how enzymes are used in washing powders, beer industry, the soft drinks industry, and dairy products. And at the end of the chapters, you can see there on the right hand side, we give the opportunity to students to, if they decide to do a project on this topic, they can look at the importance of enzymes in healthcare, or as you can see, enzymes in the digestive system as well. So if you go on there to the next slide there, chapter 2. Chapter 2 there, you'll see there the skeleton. So again, a topic that used to be on the old Junior Cert course, and a topic that students used to love doing. So we introduced the idea of what used to be on the old Junior Cert course, the features of the skeleton. We look at joints and muscles, and we introduced the idea of just like an axial skeleton, a perpendicular skeleton. We look at them features in a little bit of detail. If you go over to the next slide there as well, you'll see there we introduced the idea of the backbone and how it's made up of vertebrae and the number of each vertebrae. We also look at, you see on the right hand side there, is the synovial joints, what used to be always on the old Junior Cert course that students used to love. We look at the idea of the hinge joint, the ball and socket joint, and how tendons and ligaments are such important features of the skeleton and of the joints. And again, you see these pop-up boxes there. Did you know? So we introduced the idea of the ACL and how it's such a dramatic effect on sports people who have injuries in that area. So again, we always make it relevant, each topic, to the students' everyday life. On the next slide there as well, you'll see we look at the muscles. Remember, the muscles used to be always on the old Junior Cert course, the antagonistic muscles. We bring this back and we introduce this enjoyable topic to the students. And you can see there in the bottom right hand corner, you'll see there how antagonistic muscles work. For example, you see there in relation to students lifting weights, or a person lifting weights, how these muscles work to allow the weights to be lifted. So these questions are based, and you see there within this PowerPoint slideshow today, these questions are dotted throughout each chapter. These questions are not just at the end, they're dotted throughout each chapter. So that gives students and teachers opportunities to test their knowledge on what they've just done. On the next slide there as well, you'll see again at the end of every chapter, and we do this again for the skeleton, we look at a case study on arthritis, we look at a case study on rickets. These things are mentioned briefly in the Leaving Cert course, but we take this opportunity in TY to look at them in a little bit more detail, so it makes it more interesting, more relevant to the student. And again, if the student decides to do so, they can do a project on osteoporosis, or maybe in the ACL injury area, and it gives students it lets them develop that area, and they look as you can see, there's some points there provided for the students, so it gives them ideas of where to maybe research, and they can go into them areas in a much more detail. On the next slide there, chapter 3, you'll see there in chapter 3, excretion. Again, another topic that used to be on the old Leaving Cert course. That's now not approached until Leaving Cert biology. And you'll see there excretory organs and products are going to be looked at here. The urinary system will be looked at. And you can see on the right hand side, we have a lovely image of the 3 excretory organs and what they excrete. And again, on the next slide, if you flip over to the next slide there, you'll see there again the old diagram that used to be on the old junior cert course of the urinary system. We bring this back into play. We look at how these blood vessels are so important to the kidney and the urethra, and how it's involved in carrying urine to the bladder. And again, you can see there little did you know boxes that I have to say are interesting facts that I think will really bring these topics, make them much more relevant to the students' everyday lives in relation to how they affect the student's body themselves. On the next slide there, you'll also see, again, we look at this in a little bit more detail than the old junior cert course, but not as much detail, obviously, as the Leaving Cert course. We look at the cortex and the medulla in relation to filtration and reabsorption, but we don't reference the nephron at all. So we look at these areas, like the cortex filters the blood, and the medulla then reabsorbs all the useful materials. And we then bring in the ideas. You can see there a pop-up box there, did you know? We bring in the idea of people that suffer from diabetes. One of the tests you do, you look at your urine, and you see how there's high glucose levels. And we relate that to the kidney, in that because the insulin levels are not sufficient, that the glucose levels are so high in the blood that the medulla of the kidney, they can't reabsorb all the glucose, and therefore glucose sometimes ends up in the urine for people that suffer from diabetes. So again, it makes it relevant to students and what they really want to know. On the next slide there as well, you'll see again questions that are these questions are dotted throughout each topic in 2 or 3 different locations. So again, it gives students always the possibility to look at and assess what they already know and see, do they know it that well. On the next slide there as well, you'll see, again, a case study. At the end of every chapter, we look at 1 or 2 case studies. We look at kidney stones that a lot of students often heard of but don't actually know what they are. And then we look at dialysis. So these are 2 really interesting areas that students often love finding out about, but never get the opportunity to do so, even in Leaving Cert biology. And again, you'll see a couple of 2 or 3 project ideas, the bottom right-hand corner, if students decide to do them on dialysis or chronic kidney disease and kidney failure. On the next slide there, you'll see chapter 4. So chapter 4, we look at the nervous system in relation to the structure of the nervous system. We look at reflex actions. We look at the brain. And again, you'll see there on the next slide, you'll see there we look at the idea of the central neuron, the interneuron, the motor neuron. So we look at it's really the basic functions of what these 3 neurons do. And you'll see there again, every opportunity we have these pop-up did you know boxes that make it much more relevant to, again, the student, and it hopefully pulls their interest into increases their interest in the topic even more so. And again, you see there in the bottom right hand corner there, just before you flip over, the idea of pins and needles that a lot of people often affects a lot of people, but a lot of people don't understand why it happens. On the next slide there, you'll see there also we look at the diagram of a central neuron and a motor neuron, and we look at it in some sort of detail, but we don't go into the Leaving Cert detail of it. So we introduce the idea of the myelin sheath and how it insulates the movement of that electrical impulse. On the next slide as well, you'll see there again, questions are dotted throughout, just to always give the student the opportunities to assess their knowledge. And on the next slide there, you'll see also you'll see there the idea of a reflex action. Now, I know this wasn't done in old junior cert course, but I think it's such an interesting area for students to maybe hopefully encourage them to do Leaving Cert biology. So the idea of reflex actions, we look at the examples of them, we look at the advantages of them, and we look at briefly how the idea of how it works as well. On the next slide, you'll see there also that we look at the brain. We look at the areas of the brain. We look at some basic functions of the different areas. But again, we bring in the idea of some did you know boxes there, the idea of a stroke and how it affects the functions of the brain. And you look at the bottom left-hand corner, a little did you know box, like the idea of ice cream and why that can sometimes cause brain freeze. And we link that, we look at how that affects, how that comes about in relation to the nervous system. On the next slide there, You'll see there again a case study in relation to this. So you see there a case study on MS that affects so many people in this country. And again, we look at a case study of the sciatic nerve. And again, things that are mentioned sometimes in the Leaving Cert course, but don't go into any sort of detail. So it gives the student an opportunity to look at this information that they find interesting and also relevant to maybe experiences they've had as well from people that they may know. And also you'll see there are a couple opportunities if students decide to do so. Parkinson's disease, a project on that, or maybe even Alzheimer's. On the next slide there, you'll see Chapter 5, we look at the senses. So again, an old topic that used to be on the old Junior Cert course that again really isn't mentioned at all in the new Junior Cert course. So you'll see there the skin, the tongue, the nose. We introduce them three in a very basic way. The eye and the ear, we go into a lot more detail. So you see there on the bottom right hand corner, we look at the tongue. We do the old taste test that students find really, really interesting. On the next slide there as well, you'll see there, we look at the eye, we look at the structure of the eye, we look at the functions of some parts of the eye, and then we bring in a few fun activities that we, on the bottom left-hand corner, identifying things like the blind spot, and then we do the old switch the light on, switch the light off, for looking at how pupils change in size and so on. And again, we try to relate this to, again, make it relevant to the students. So we look at the bottom right hand corner there, a little did you know box there, and we introduce the idea that why do predators have their eyes facing forward, and why do animals like herbivores have their eyes facing sideways out of their skull, and we introduce that idea and why their eyes are positioned like that. Which is again referenced in the Leaving Cert course as well. On the next slide there, you see there as well. So we look at the ear, and we go into the ear in a little bit of detail, not as much detail obviously as Leaving Cert biology, but we introduce the idea of how the ear works. And we look at then, again, interesting did you know boxes like why does your ear pop? And the function of earwax, and why elephants have the largest ears in the animal kingdom. So we look at all these interesting facts, and we look at grommets and so on, and glue ear that is referenced in the Leaving Cert course as well. On the next slide there as well, you'll see there, we look at again a case study. These case studies students find really, really interesting. So students often hear of long-sightedness and short-sightedness, but they can't really distinguish one from the other. So this gives the student an opportunity to really look at the difference in the two, and why how these conditions can be corrected. And again, you see on the right hand side there, we look at color blindness, a possible project on that. We look at a possible project in cataracts. I give the students some interesting pointers that they might go and research, so they can have a bit of a direction where their project might go. On the next slide there as well, you see there on chapter 6 there, microorganisms. Now the last three chapters are obviously referenced in the new Junior Cert course, but we look at them in a little bit more detail. So again, students have that little bit of a head start when they go and do the Leaving Cert biology course. So we look at bacteria, we look at viruses, we look at the disease and immunity, and we look at the basic structure of a bacterial cell on the bottom right hand corner. On the next slide there as well, you'll see there we look at like how misusing antibiotics can lead to antibiotic resistance, which students find very, very interesting. We also look at the basic idea of a virus. We don't look at we don't go into the detail of how a virus replicates, but we look at the advantages and the disadvantages of viruses. And you can go on to the next slide there again, and you'll see there we then look at how our immune system helps fight off these bacterial or viral infections. So we introduce the idea of immunity in relation to the skin, in relation to the stomach, and how stomach acid helps that. But we also introduce the idea of active immunity and passive immunity. This is a topic that's thrown at students in Leaving Cert level, and a topic they find very difficult. So we take this opportunity to give the students a little bit of knowledge about active immunity and passive immunity, and again, make it relevant by introducing examples in these pop-up did you know boxes there. On the next slide there again, you'll see, again, we take this opportunity to introduce some case studies on the idea of the importance of vaccines. So in Leaving Cert biology, they look at what a vaccine is, but we really don't go into how vaccines have impacted on our lives over the last 40 or 50 years. So we remind students about smallpox and how terrible that was and how vaccines have basically eradicated that disease off the planet. We look at a couple of possibilities of students, if they decide to do so, they can do a little project on polio or measles, and again, there's some pointers there provided to them. If you flip over to the next slide there, you'll also see there chapter 7, DNA was on the old junior cert course or the new junior cert course, but we look at this DNA in a little bit more detail. We look at its structure, and we introduce the idea again that DNA is a code, and this code instructs the cells how to make a protein. And we remind students that when this DNA code is incorrect, that genetic disorders can then appear, such as cystic fibrosis. On the next slide there, we also look there at, if you flip over to the next slide there, you'll also see, so you'll also see there, we introduced the idea of a haploid cell and a diploid cell, just the basic idea of them. And if you flip over to the next slide there as well, we then bring in the idea of cell division, mitosis, meiosis. We do not look at how it happens. We only look at basically what mitosis and meiosis is, and we look at how these two types of cell division, we look at their functions, how they impact on single-celled and multicellular organisms. So very, very basic, but yet giving students a bit of a head start in leaving cell biology. Over on the next slide there, very quickly, you'll see there, again, a case study. We look at cancer and relation to mitosis. When mitosis occurs too often, too quickly, it can lead to a condition of cancer. And we look at some possible projects there in relation to DNA, cystic fibrosis, and sickle cell anemia. Finally, chapter 8, you'll see there, I just see time is against us here, so we'll just mention this very, very briefly. In this last chapter, there's nothing, we look at monohypercrosis, and if you very quickly flip over to the next slide, you'll see there, we introduced the idea of also, we look at the idea of incomplete dominance, and also, we also look at the idea of sex linkage, but we keep it very, very basic. We allow the students to follow, and you look at the bottom right hand corner, we allow the students to follow step by step what they have to do to carry out this simple genetic cross. Very quickly, if you go over to the final slide there, so a quick summary here just to finish up today. All 3 publications, all 3 books give complete flexibility to the teacher, as each chapter is a standalone topic to help bridge the gap between the junior cert science and the leaving cert science subjects. Also, the emphasis on these 3 books is on science, technology, and society, and it shows the relevance of the various topics to our everyday lives. Also, remember, the 3 books include many case studies, many real-life scenarios that help to interest the students in the study of biology, chemistry, and physics, and it encourages them to continue with their studies, hopefully onto leaving cert level. Also, remember, there's also many opportunities to do research projects to allow students to develop their research and their analytical skills. And remember, in every single book, there's an abundance of structured questions to allow the students to chart their progress and to allow for them to find out what they understand in each topic. And the last 2 points there, remember, there's many experiments, practical work included in the books, so it allows students to develop these key skills for leaving cert biology. And finally, just remember what these books are all about is to give the student a bit of a taster of what to expect in leaving cert biology and give them a bit of a head start there as well. Thank you very much there, Connor, and I'll throw it over to you there.
That's great, Wesley. Thanks so much. Brilliant. And thank you, Declan and David, and thank you also, Sean, for wonderful presentations and walkthrough of the books and to talk a little bit about the transition year science approach that you've all so effectively presented on there. So look, I know the time is up against us a little bit, but I still wanted to take the opportunity to take some questions. So I'll very quickly just mention to everybody here that if you're interested in these books and you'd like to find out a little bit more of them, please go to folens.ie, and if you run a search for something like transition year, bridge the gap, chemistry, physics, or biology, you'll be taken to web pages that include some sample pages from the book and a bit more information on each of those publications. In relation just to some special offers that we're running at the moment, particularly for people who've attended today, we're offering a 30% discount for a full set, TY set for 1 subject. And if you wish to adopt 3 full TY sets, we're offering a 40% discount on the recommended retail price, which I believe is €12. And also the books, just for anyone who wants to buy them in the shops, are available in any of the large retail outlets, online or on the high street. And just to point to there as well, the fact that it's not just science that we've developed Bridge the Gap publications for. We also do it for English with Paul McCormack, for Gaeilge with Hugh Gallagher, PE, Physical Education with Fergal Lyons. Then we have our wonderful science books, and then Oliver Murphy has written a brilliant transition year maths book. And then finally, coming out next year, we have Lucy Gallagher's transition year Spanish book. So if you have any interest to learn a little bit more or to discuss adopting those books, please contact your local Folens rep. They're available for calls or appointments at any time that suits yourself. We also offer support for book rentals. Books are available to view on folens.ie, as I mentioned earlier on. And if you go onto folens.ie and enter your area, you'll be able to find your rep and their contact details. So I'll spend a couple of minutes, if you don't mind, for those who are still with us, going through Q&A, I should say. Declan, David, Sean, Wesley, I hope you can hear me. You're there. I can't see
yeah, thanks, Connor. No problem.
So there's a couple of questions. There's one that relates to planning and covering of the book. There's a couple actually related to planning. I might come to last if we have time, but I'll go into some of the specific stuff just to begin. So I might put one to Declan initially. There's a comment here that says, in his talk, Declan mentioned about the appendix with the summary table for writing the formulas of ionic compounds. They mentioned they really like this idea. Could a similar table be produced for writing the formulas of covalent compounds? I've no idea what that means, Declan, but I'm sure that you do.
Yeah, it could, of course, but it would be a very big table. Now, in Essential Science, in the chapter dealing with the periodic table and chemical formulas, there is a table there summarizing all the ones at junior cycle science. There is also a table in the transition year book summarizing the greenhouse gases. If one were to make a table then for all the organic chemistry ones that you come across, it would be very big. So my advice would be to use smaller tables rather than just one big table, because it would be enormous. It was much easier to do for the ionic compounds, because on one row you can have a huge pile of ionic compounds. But if you were to do it for the covalent, it would be an enormous table. So my advice is use smaller tables and use lots of them.
Great, thank you, Declan. Stick with chemistry. David, lots of positive feedback coming through on the forensic science chapter. It's really struck a note there. One of the comments says, I have never taught forensic science to TY students, but I would like to try it out this year. It's about equipment. I have very little equipment and I usually buy everything from Lennox Lab Supplies. Are there any forensic science kits available from them?
Yeah, thanks very much, Connor, and thanks to the person who wrote in that question. So firstly, a lot of the equipment that I'm using or that I have used, including the book, is regular stuff that you would have around the lab already. Lennox do kits available for forensic science that are available. If you just look up their catalog online or contact your rep there is ones that you can get just for very basic fingerprinting kits. There's ones for to do blood grouping and stuff like that as well. And a lot of the chemicals then obviously that I've been using in the chapter are available from them. As well as that, as I mentioned, there's stuff very easy to pick up from €2 shops, supermarkets, arts and crafts shops and things like that as well. So definitely have a look around. I've just gathered them up over the years, but they are all available from the main suppliers like Lennox. Yeah.
Okay, thanks, David. I might switch to Sean now. Sean, I've got a question from a teacher. They say, I'm not a specialist physicist teacher, but interested in teaching at a transition year. Is this book suitable for me?
Thanks, Connor. I suppose when I was writing and Robert was writing this book, we were very cognizant that a lot of teachers may not be physics specialists. And in a way, for that matter, transition year students could be put off if we wanted significant mathematical treatment of these subjects. So to be honest with you, the book is laid out at junior cycle level. So anybody who taught the old junior cycle course, or preferably the one before that even, they would have absolutely all of the skills necessary. It's just a small little bit of additions to a few bits and pieces to it. But the thing about the book is you can dip in and dip out as you see fit. If there's a part that you find in waves or motion or anything like that, you can let that out. But then you can go into, if you wanted to, and do magnetism. So again, you can dip in and dip out as you see fit. So it is designed with a minimal mathematical treatment and a lot more visual and practical work. So I would think, Conor, that it would be very user-friendly in that regard.
Okay, and just maybe sticking with you, Sean, it might be something that applies to the other subjects, but do I need new lab equipment for TY, these books?
Most of the stuff is actually on the indicative lists. So any school that was equipped in the last 30 years should have the equipment. A lot of the stuff would be relevant to the previous junior cert cycle syllabus, and a few bits and pieces you may have to ask the physics teacher for, but most of that is in the indicative lists in the labs. So you need to, I don't think you have to connect to purchase almost anything new. Okay, so from the point of view of equipment, it's not a problem.
Okay. I'm conscious of time, but I might ask one or two more questions, and if I might maybe switch to you, Wesley. A lot of questions coming through, I suppose, about the books, and I don't think we have time to cover it now because it's a lot of it is to do with planning and how much time you need to teach the book or a chapter and so on. And I know this is probably coming at us because TY is taught differently and timetable differently in different schools, and there's lots of different activities that might impinge a little bit on the timetable. So you have to be flexible to a large degree, I suppose. But I suppose just one of the general questions that's come through a couple of times is, for, you know, in the case of biology, how many classes would be necessary to cover a typical chapter in the book? I know they're all pretty uniform in size. So
Yeah.
how many classes would be necessary for one?
Yeah, well, look, as I say, like, it depends. Depends on the teacher. Like, sometimes biology is taught in a module for maybe September, October, and sometimes the students might be doing it for the entire year. So the book is designed in a way to be very flexible, and so is the chemistry and the physics books as well. So again, like Sean said, teachers can decide to do maybe the entire chapter. And biology, if they decide to do an entire chapter, it may take maybe it may take 5 or 6 classes if they decide to do that. It depends on the length of the class, if it's a 40-minute or an hour class. But the whole idea of it is, like, TY is there's so much going on. So the whole idea of it is just to make a book that students can dip in and do a part of a topic, but yet come back maybe a few days later, maybe because they're out with work experience, and not feel lost, but come back in and rejoin it and still be able to get on quite well with the topic, you know. So it's just designed to be flexible. So but as a chapter for biology, you'd be talking maybe 6 or 7 classes, just depending on the length of the class, you know.
Great. Thanks for that, Wesley.
No
I'm we're nearly at 8 o'clock already. Sorry, Declan, were you going to say something there? Maybe not. Sorry. So look, that's it pretty much. I know we're almost at 8 o'clock now. Lots of positive feedback we're getting on the transition books in general. I know there's some requests for other subjects even coming through, ag science, and that's definitely an area that we're looking at. And just generally, we're really pleased to see how much positive feedback we're getting. The Bridge the Gap series across the board, but particularly for the science subject. So that's fantastic. I won't keep you any longer. Only just a quick reminder that if you wouldn't mind when you leave to complete the short survey that we have for you. All I think that really remains is for me to firstly to thank our authors. So Sean, Robert, who's not here, but then Declan, David, and Wesley, for all your efforts in writing the book, such great publications, but also such great presentations today. And to everyone out there who stuck with us on this slightly longer than intended webinar, we really do appreciate it. Thanks so much for your time, and we hope you have a lovely evening. Thank you, and goodbye.